Here is question number 11 from 3-2. Um, so this question is having us use Chebyshev's inequality to estimate the percentage of a distribution that's so many standard deviations away from the mean. Okay, so Chebyshev's inequality is right here. Okay, it's 1 minus 1 over k squared times 100%, where k is just the number of standard deviations. So if we want to know, um, what's 3.5 standard, what percentage of the distribution is 3.5 standard deviations to either side of the mean, we can just plug 3.5 in here. And you'll notice that both Chebyshev's inequality and the empirical rule give us ways to estimate the percentage of a distribution. The empirical rule assumes, though, that the distribution has to be bell-shaped, kind of symmetric, that nice bell shape. And so Chebyshev's inequality is nice in that it doesn't require that at all. Of course, it won't give you as tight of estimates because it doesn't have as much information about the distribution, but it gives you a minimum on the percentage of a distribution between two numbers of standard deviations. The one caveat is that k has to be more than 1, so it's not useful for standard deviations below 0.1. Okay, so let's look at this actual problem. We have the average price per gallon of gasoline is 3.72, and the standard deviation is 0.09. And we're asked to find what percentage of gasoline stations had prices within 2 standard deviations of the mean. Okay, so we can go to Chebyshev's inequality, right? And we just plug in 2 for k. So if k equals 2, then I just square 2, and I get 1 minus 1/4. Sorry, my picture's kind of in the way here. 1 minus 1/4, which is 3/4 times 100%, which is just 75%. So I can go back in here and I say at least 75% of gasoline stations will be within 2 standard deviations of the mean with their prices per gallon. Okay. Now we're going to ask the same questions, although we change the standard deviations to within 2.5 standard deviations of the mean. This, we're of course expecting a bigger percentage than 75, right? Because we're allowed to vary more away from the mean. So here we just plug in 2.5 instead of 2 for k. And we square it, we get 6.25. And 1 divided by 6.25 is 0.16. And then we subtract that from 1 and we get 0.84. So this is 84%. So 84% of the gas stations will have prices between 2.5 standard deviations away from the mean. Now, there's a second part of this question. The gasoline prices are within 2.5 standard deviations of the gasoline prices that are within 2.5 standard deviations of the mean are blah and blah. So here we're actually putting the price limits on it, right? Like, well, we know with 84%, at least 84% of the gasoline stations will have prices within 2.5 standard deviations, but what are those prices on either end? Okay, and all we have to do there is figure out what 2.5 times the standard deviation is. Well, we're given in the problem that the standard deviation is 9 cents, so 2.5 times 9 cents is 22.5 cents, right? So 84%, at least 84% of the gas stations are going to have prices that are to 22.5 cents to either side of the mean. Okay. Now to find the upper price, right, we just take the mean, that's the mu, right? That's the fancy letter for that, times 2 times the standard deviation. Actually, this would be 2, should be 2.5. My bad. I didn't write that correctly. So 3.1, here's the mean, right? $3.72. And here is 2.5 times the standard deviation, the 22.5 cents. So I add that on and I get $3.94, 94.5 cents. right? Same thing I do with lower bound. The only difference is that I instead of adding the 22.5 cents to the mean, I subtract it to get the lower bound. So there I've got, what, $3.49.5. So I'm just going to put those in. I think it wants me to put the whole thing in. 3945 and 3495. 495. Okay, so I got that. Now, what percent is the minimum percentage of gasoline that had prices between 3.45 and 3.99? Now, to be able to figure that out, we need to know how many standard deviations above and below the mean this is. So that's, once we figure that, we'll know what K is, and that we can plug that into Chebyshev's inequality. Okay, so to do this, we just, find the difference from the mean. So we take 3.99 and we subtract the mean. And so the top price is 27 cents over the mean. Okay, the bottom price is 27 cents below the mean. Now, to figure out how many standard deviations that is, we just divide by the standard deviation, right? So there's basically 3 standard deviations in 27 cents, because the standard deviation for this distribution is 9 cents. Okay, so we're really talking about 3 standard deviations above and below the mean. That gives us our K, right? So K has to be 3. We just plug that into Chebyshev's inequality, and we get 88.89%. And they wanted us to round, it's like 0.8888 repeating, and we're just rounding it to 2 decimal places. So 88.89%. So almost right, 89% will have of the stations will have prices between $3.45 and $3.99. I hope that helps a little bit with this inequality.